Ever pondered over the magic behind stock market predictions? Today we're going to unravel that mystery. The stock market, a dynamic and unpredictable beast, holds an immense fascination for many. The ability to predict its movements can lead to significant financial gains, making it the holy grail for investors, economists, and finance students alike. But how is it possible to forecast something so seemingly erratic? Are these predictions mere educated guesses, or is there a method to the madness? These aren't just random stabs in the dark or hunches based on gut feelings. Quite the contrary, stock market predictions are a science, backed by complex mathematical models and algorithms. They are a result of intricate calculations and analyses performed on historical data, using various factors such as past prices, volume, trends, patterns, and even global economic indicators. Now, you might be wondering, what are these algorithms and mathematical models we're talking about? Well, there's a myriad of them, each with its own strengths and weaknesses. But today we're going to focus on one particular algorithm that has proven to be incredibly effective in predicting stock market trends. It's called the ARIMA algorithm. ARIMA, standing for Autoregressive Integrated Moving Average, is a forecasting algorithm that's widely used in time series analysis. Time series analysis, in case you're wondering, is a statistical technique that deals with time series data or data points collected at specific intervals of time. So the ARIMA algorithm uses past data to predict future data points, making it a powerful tool in forecasting stock market trends. But just like anything else in life, the ARIMA algorithm isn't perfect. It has its limitations and isn't always the best fit for every scenario. But we'll get to that later. For now, let's delve deeper into what ARIMA is and how it works. So the secret ingredient behind these predictions is an algorithm called ARIMA. Intriguing, isn't it? ARIMA stands for Autoregressive Integrated Moving Average. Sounds complex, doesn't it? Well, it's not as daunting as it sounds. Let's break it down. First up, autoregressive. This part of ARIMA takes us back to our high school math classes. Remember linear regressions? They're equations that help us predict a dependent variable based on the values of independent variables. In the case of ARIMA, we're predicting future data points based on past values, hence the auto in autoregressive. Next, we have integrated. This refers to the process of making a time series stationary. Now, a time series is simply a sequence of data points indexed in time order. But what does it mean for it to be stationary? Well, a stationary time series has properties like mean and variance that remain constant over time. This is important for ARIMA as it works best with stationary data. And finally, we have moving average. This is another statistical calculation that's used to analyze data points by creating a series of averages of different subsets of the full data set. In the context of ARIMA, the moving average model is used to understand the error between the actual and predicted values from the autoregressive model. So to put it all together, ARIMA is a forecasting model that uses the concepts of autoregression, moving average, and differencing to make the series stationary, to predict future points in a time series. It's like trying to predict the next word in a sentence by only looking at the previous words. The beauty of ARIMA lies in its versatility. It's used in an array of fields, from economics to meteorology, and yes, even in predicting the stock market. It might not give you the winning lottery numbers, but it can certainly provide a statistical basis for some educated guesses. In essence, ARIMA is like a crystal ball using the past to predict the future. Now that we know what ARIMA is, let's delve into how it actually works. ARIMA, which stands for Autoregressive Integrated Moving Average, is a forecasting method that uses three key components to predict future values. Each of these components, AR, I, and MA, plays a unique role in the prediction process, starting with the AR, or autoregressive part of ARIMA. This component assumes that the current value of a series is dependent on a certain number of past values. For example, today's stock price could be seen as a function of the stock prices from the past few days. It's like looking over your shoulder to see where you've been before deciding where to go next. Next up is the I, or integrated. This is the bit that deals with the trend in the data. It subtracts the previous value from the current value to make the series stationary. That is, to remove any trend or seasonality in the data. This is crucial in time series analysis, because most statistical forecasting methods are based on the assumption that the time series is approximately stationary. And finally, the MA, or moving average component. This part assumes that the error of the current value is a combination of the past errors. It's like learning from your mistakes. If a stock price was overestimated in the past, the moving average component takes this into account to adjust future predictions. Together, these three components form a sort of checks and balances system for forecasting. The autoregressive component uses past values to predict the future, the integrated component removes trends to ensure the data is stationary, and the moving average component learns from past errors to adjust future predictions. So, in simple terms, ARIMA is like a seasoned trader who uses past data, adjusts for trends, and learns from past mistakes to predict future stock prices. So ARIMA combines these three components, each playing a unique role to make a prediction. Knowing how ARIMA works is great, but seeing it in action is even better. Let's imagine a simplified scenario. You're an investor who has just discovered the ARIMA model, and you want to use it to predict the future price of a particular stock. Let's call this stock X. You've gathered data on stock X's price changes over the past 5 years. This is your time series data, the raw material ARIMA works with. ARIMA stands for Autoregressive Integrated Moving Average. These three components are the pillars of the model. The AR or autoregressive part refers to the use of past values in our time series data to predict future points. In our case, it means using the past prices of stock X to forecast its future prices. The I, or integrated part, is about making the data stationary. In simpler terms, it means transforming the data so it doesn't show any trends or seasonality, which can distort the results. This might involve subtracting the previous value from the current value, a process called differencing. The MA, or moving average part, is about smoothing out the data. It uses the error terms from previous forecasts to make future ones. This helps in reducing the random fluctuations and making the data more predictable. So you feed your data into the ARIMA model, and it uses these three components to make a forecast. It might predict, for instance, that the price of stock X will increase by 2% next month. You, as an investor, can then use this information to make informed decisions about buying or selling stock X. It's important to remember that ARIMA, like any model, is not infallible. It's a tool that uses past data to make educated guesses about the future. But as we all know, the stock market can be influenced by a wide variety of factors, many of which can't be captured in past data. And voila! That's how ARIMA helps predict future stock prices. But wait, is ARIMA infallible? Unfortunately, no algorithm is perfect. Now let's talk about the limitations of ARIMA, the not-so-glamorous side that we need to be aware of. ARIMA, like any other statistical model, is built on certain assumptions. One of these is linearity. It assumes that the relationship between variables and the future values they predict is linear. While this might hold true for many scenarios, the real world, especially the stock market, is not always linear. It's dynamic, complex, and often non-linear. So, when the relationships between variables become complicated, ARIMA might not be your go-to model. Another assumption that ARIMA makes is that the underlying data is stationary, meaning that its statistical properties do not change over time. But let's face it, the stock market is anything but stationary. It's influenced by a myriad of factors: economic indicators, political events, even tweets from influential figures can cause sudden shifts in trends. This brings us to another limitation of ARIMA. It struggles with sudden unexpected changes in trends. Remember when the housing market unexpectedly crashed in 2008? Or when the tech bubble burst at the turn of the millennium? These are known as structural breaks, and ARIMA tends to fumble when faced with them. It's not designed to predict these sudden shifts, and as a result, its forecasts can go awry in such situations. And let's not forget, ARIMA is essentially a time series model. It relies heavily on past data to make future predictions. So, if the past data is erratic, missing, or unreliable, the predictions made by ARIMA could be significantly off the mark. So, while ARIMA is a powerful tool, it's always important to remember its limitations and use it judiciously. Remember, no tool is a silver bullet. It's all about choosing the right tool for the right job, and sometimes that might not be ARIMA.